All right, on page 2 of your notes, big idea. If you want to investigate limits of functions as x heads toward positive infinity or toward negative infinity, the easiest way to do it is by considering which term or terms will dominate in the expression. So remember in the last video, we were trying to figure out what happened to the function x divided by square root of x squared plus 1. And we said that as x got really big, that little plus 1 didn't really have an effect on the value anymore, so it became insignificant, which means that it was the x squared term inside the radical that was dominating. So we're going to focus on the terms that dominate. There's a place for you to write in 2 examples. It's not exactly example 7a in your book. Well, actually, I didn't check your new book. It's example 7a in the old book. It's probably the same one. But I've modified it slightly. So if I were to ask you to find the limit as x went to infinity of this rational function, remember rational function means big fraction function, you would think about which term in the numerator is going to matter the most in determining the value of the numerator, and which term in the denominator. Well, as x gets bigger and bigger toward positive infinity, and notice this technique only works when we're thinking about limits at extreme ends of the graph. If this were a 0 or a 1 or any other number that wasn't positive or negative infinity, this technique doesn't work. But in the numerator, the term 2x to the 5th is going to dominate, and in the denominator, 3x squared is going to dominate. So I can rewrite that limit. Whatever this limit was, it's going to be the same as thinking about this newer limit of this newer, smaller, less complicated function. Well, if I have 2x to the 5th divided by 3x squared, now I can perform algebra. I can factor out an x squared from the numerator and denominator and cancel them. And now I'm down to here. So whatever this original limit was, it's going to be exactly the same as the limit as x goes to infinity of 2x cubed over 3. So now I have to think. I have to imagine using using infinity, something really big, in place of x cubed. And I don't have any denominator dividing anything away. So that's going to grow without bound. So the limit as x approaches infinity of 2x cubed over 3 is infinity. So that means there's no number that caps it. So you could say that the limit is infinity. It's equivalent to say the limit does not exist. To say that the limit is infinity is not a limit, right? Means the same thing as the limit does not exist. So you could give this answer or this answer on the AP test. They both get full credit. What if, looking at the terms that dominate, actually do give us, so let's just read this here. Since there's no limit as x approaches infinity of the rational function we started with, this function, if I graphed it, would have no horizontal asymptote. What about this one? What if I wanted to find the limit as x goes to infinity of this rational function, which is a little bit different in a very important way than the one we just saw? I'm going to think about the terms that dominate, one for the numerator, one for the denominator. Now, I have to warn you that here, because in textbooks, a lot of times we want to be very formal. We typically present our polynomial expressions in descending exponent order. So the numerator and the denominator, they were lined up so that there was the x cubed term and the x squared term and the x term and then the constant. And that's nice. I just don't want you to jump to the assumption that it's always going to be the first term from the top and the first term from the bottom that dominate. It has to do with the exponent, right, or the nature of the function. So when I look up here in the numerator, all of those terms are polynomial terms. They are multiples of powers of x. So the one that is most affected by x getting big is the one with the biggest exponent. So that's why I picked 2x cubed for the numerator and why I picked 5x cubed for the denominator. It is not because they were written first. So I would almost guarantee that on the AP test, you'll have a problem like this. And you might just expect the terms might be written in a different order. It's your job to notice, in this case, which one has the biggest exponent. So now I've decided that those two terms dominate, and I can consider this a much less complicated function. Notice this time I have an x cubed that perfectly matches that x cubed, and those are going to cancel. Now I have the limit as x goes to infinity of 2 over 5, which doesn't depend on x at all, and is always equal to, the limit of a constant is always equal to that constant. In this case, since I did find a limit as x went toward infinity, right, this is my b, so I would have a horizontal asymptote at y equals 2/5. All right, so here's your practice for that new big idea. To find these limits as x approaches positive infinity or negative infinity, you're going to be checking for the terms that dominate in the numerator and denominator. Don't forget that I'm also asking you to state at the end, depending on the limit you find, is there a horizontal asymptote, and if there is, where is it?